So that's what a relation is. So now our big definition oh, and by the way, that reminds me, we have one more thing that's a great common relation. We have the globe here, right? Sometimes call it a map, right? And the interesting thing about a globe or a map is that everything on this relates to something on the actual Earth. So like right now, I'm pointing at Mexico. Here's where Mexico is. That on the map / globe, that relates to Mexico on the actual Earth. The U.S. is here. That relates to the U.S. on the actual Earth. A lot friggin' what's this? Quebec. Quebec is here. That relates to Quebec on the actual Earth. So a map is itself a relation between the Earth and this thing right here, which is kind of interesting, which is why we're going to use the word map for functions in a second. But anyway, because it literally gives us like a map to look at to take us from one place to another. But anyway, so a definition of a function. So a function is simply a relation, a function from A to B is a relation between A and B that is well defined. So it's a relation between A and B that is well defined. And what's it mean to be well defined? This means every A in A relates to exactly one element of B. So just the exact same definition before. So the important thing is a function is kind of a one-way situation. So the idea of a function is we have these relations, right, where we have crisscrossing lines, all that kind of stuff, right? But a function really wants to be specifically ones where you can actually use it to go from one set to the next set. And so if it's like, so if we have, you know, if we go back to the class and the friends example or whatever, then you have DV, you have Chandler here, and I connected here, or whatever. Like with a function, you want to, if you had a function between the class and friends, that's something that you can plug any one of us into and you'll tell us which friend we are. It won't give us multiple options. It's not like, oh, Liam's a Phoebe or a Ross. No, it's Liam is a Phoebe or Liam is a Ross, right? A function wants to have one defined thing. And also there's no such thing in a function of not relating to anything. It needs to relate to everything. A function is we want to use a relation to be able to tell us, if you give me something in A, I will give you the thing it relates to in B, the one exact thing it relates to. So that's interesting. It's kind of a new thing. And it works one way, by the way. A function, every A and every element A, intercept A, must relate to exactly one element of B. That does not say that every one element of B can't relate to multiple things in A, right? This function might send multiple different A's to the same B. That's fine. So I really like to think of a function. The way I like to think of it is I like to think of, so I have a set A here, like A1, A2, A3, A4. We'll have a set B here, like B1, B2, B3. I think of a function as literally like this laser gun, this laser beam machine here that, let's see here. That literally tells you where to shoot, like where that literally tells you Like if you plug in any element of A into this F, it'll shoot it over to that B. It'll tell you that's where it goes. So A goes there. A2 goes to B1. A3 goes to B2. A4 goes to B3. I like to think of it that way because that's kind of literally what you're doing. You're plugging something in F, and it's taking you to where it is in B. Kind of interesting. Now, the important thing about functions is it has to be well defined. And here, notice this is well defined because every A here only goes to one thing in B. Now this B was hit by two things in A. A1 and A3 both go to B2, but that's okay because A3 and A1 they each go to one thing, B1, or like they don't go to multiple things or zero things. We know what the output of each of those is, so it's fine. We have a word for this, a word for functions that, a word for functions like this, where two things in the input map to the same thing in the output. That's called not being one-to-one. One-to-one functions are ones where this doesn't happen. So we can do some examples. Where's my example sheet? Here it is. So if we have like A here and B here, let's say we have 1, 2, 3, pi e to the square root of 2. And we go like this. So 1 goes to pi and it relates to e. And then 2 goes to the e and 3 goes to the square root of 2. Is the function defined by this well defined? And notice what I mean by the function defined by this is I literally mean that f of 2 equals e, f of 3 equals the square root of 2, and f of 1 equals pi slash e. That's not divided by, that's like, it goes to both. So is this well defined? We're getting a chat incoming. Patrick says no, and I believe Patrick says no is because of this right here. 1 maps to multiple things. So F is not well defined. And we say maps. Maps is like the verb of going through F. So when you go through F and hit an element in B, that's mapping A to that thing in B. And it's called maps, just like I was talking about with the actual map, right? Because maps, in a certain sense, map the real world onto a very 2D nice little map. Like literally you could think of arrows from everything in the real world pointing to the thing on the map. Interesting. Anyway, yeah. What if so we can change this, right? We get a 1 here. And let's just say it doesn't go here. But now, actually, let's say it does go there. It doesn't go here. But now let's say this goes away. Is this well defined? I wish we had more time so we could talk about that. So we could really mull this over, but the answer is no, it's not well defined because 3 doesn't go anywhere, right? So not well defined. Since 3 does not map to anything. So the point is you have to be able to answer the question, what is f of 3? If you can't answer that question with one answer, it's not well defined. That's the whole point of a function. The whole point of a function is one relation that you can answer what is f of 1, what is f of 2, what is f of 3. You can answer what is f of whatever for whatever in your domain. Yeah, it made sense. Yeah. Okay, that's what we got going on here. Oh, and so just to give you an example of a function that is well defined, you know, if we had, it just really doesn't matter what we call these. If we have like this This will be well defined because everything in A gets mapped to something. F of 1 is B, F of 2 is B, F of 3 is C. We just answered what is the function, map everything to with a single answer. We can even do this. Looks weird, but that's fine. That's still a perfectly valid function. Yeah.